everyone. In this video, we're going to look at the atomic weight of an atom, and we're going to kind of relate that to what we know about mass number. So I want you to look at the periodic table here. We have a couple of symbols that we have to be familiar with when we look at a periodic table. At the top center, we have the atomic number. Again, this is the number of protons that we have. So hydrogen has 1 proton, lithium has 3, sodium has 11, potassium is 19, so on and so forth. Here we have our symbol, which again is also a capital letter. Again, notice for every symbol you'll have only one capital letter. If there's 2 letters, the first letter is always a capital. So this basically uniquely represents what that element is. Next we have the name, and then we have the atomic weight. Now I want you to keep in mind that this atomic weight here is considered an average. So if we thought about our definition of mass number Z, remember, mass number is protons and neutrons. And remember, I told you, or I'm sorry, A is mass number, not Z. And remember, I told you guys earlier that you can't have a half or a third or a decimal or a fractional value of a proton, and you can't do the same for a neutron. So if I were to take 2 whole numbers, how in the world do I get 1.008? The reason is because what we see here is a weighted average. So it's the atomic weight, I'll say average. Let's spell average terribly there. Average of all the naturally occurring isotopes of that particular hydrogen. So, for example, the value here is very close to 1, which often means that the mass number of hydrogen typically is equal to 1. Now you're probably thinking, okay, well I know there's, the atomic number of hydrogen is 1. How is the mass number also 1? Well, that means that most hydrogens have 0 neutrons, which is kind of crazy, right? There's not really a neutron in the center of most hydrogen atoms. However, this 0.008 indicates to me that there's a very small percentage of them where maybe there's an isotope called hydrogen 2, in which the value of the atomic mass is 2, indicating 1 proton and 1 neutron. So if you think about it, in the real world, most hydrogens do not have a neutron because their mass number is 1. However, there's a very small abundance, what we call isotope abundance. There's a very small abundance of hydrogen that has slightly more than 1. Maybe it's 2. Now, it's not a big percentage because if you look at that average, the weighted average, kind of like how you calculate some of your grades, it's not really moving that average substantially. So I don't know the percentages off the top of my head. If I had to guess, I would say that it's maybe like 98% hydrogen 1 and then maybe 2% hydrogen 2 or something along those lines, because that's the only way we could explain to have a decimal to that, again, that third place there. So that's basically how we interpret the periodic table. And keep in mind, when we talk about mass number, that's a whole number. The average atomic mass, which is what we see on the periodic table, can suggest the most common isotope just looking at it. However, keep in mind that that's not the mass number, because mass numbers have to be whole numbers. The values you see on the periodic table, no matter what you look at, are not whole numbers. Some of them are very close, right? 15.999, very close for oxygen. 18.998, very close for fluorine, and same with nitrogen as well. These are all very close to whole numbers, but they're not, because there's a very small percentage of that isotope, either slightly bigger than 14 in this case or slightly less than 16 in this case, that change that average. So just wanted to clarify that for you.